The overall goal of this experiment is to synthesize Janus Microhydrogels that are composed of the same base material and have anisotropic thermo-responsiveness, as well as organophilic and hydrophilic loading capability, using the liquid-liquid phase separation of supersaturated N-isopropylacrylamide monomer.
This method can help answer key questions in the field of drug delivery systems, specifically for the development of advanced drug carrier, which requires hydrophilic, organophilic, dual loading capability inside a single particle. The main advantage of this method is to synthesize monodispersed Janus microhydrogels with a clearly compartmentalized internal morphology and to modulate the size of the Janus microhydrogel with the help of microfluidic device. Demonstrating the procedure will be done by Kyoung and Choi, who are my PhD students.
Use the patterned wafer obtained as described in the text protocol as the master mold for PDMS casting. Mix the PDMS prepolymer and a curing agent homogeneously at a weight ratio of 10:1. For example, use 1 gram of curing agent for 10 grams of PDMS prepolymer. Pour the PDMS prepolymer into the master mold and degas it for 1 hour in a vacuum chamber. Then, place the master mold with the PDMS prepolymer into an oven at 65 degrees Celsius for 3 hours. Cut the cured PDMS into the size of a single chip using a sharp scalpel. Carefully peel off the cured PDMS replica from the master mold by hand. Punch inlet and outlet holes into one of the replicas using a hole puncher with a slight